In this class, we will study about gravitation or gravitational force. So the first part of gravitation. So let us consider two known facts. So the known facts are the moon goes round the earth. That we know, that is a fact. An object when thrown upwards reaches a certain height and then falls downwards. That is also a fact. This is happening all the time. But only thing is, people didn't think why it is happening. So the why this is happening was no one thought till one day when Newton was sitting under a tree, an apple fell on him. That was the incident. Then he only thought why this is falling towards earth. Apple is falling towards earth. Then he thought about that incident. Then he made two kind of assumptions immediately. So those assumptions were, if the earth can attract an apple, can it not attract the moon? So if apple is falling on earth, then moon also should fall on earth or come towards the earth. Is the force the same in both cases? In the apple case as well as moon case, is it same? He is the first person who thought about that. Then he finally in himself he concluded that he conjugated that the same type of force responsible in both cases. So conjugated means without full understanding or without full information, but initially he is the first person to thought that this should be same falling apple onto earth and moon going around the earth, both are caused because of one type of force only. Then because of this kind of conjugation, so some more questions arised in him. So apple must be attracted by earth. Okay, if apple is attracting, earth is attracting apple, but apple also should be attracting earth. In that case, but we don't see the moon falling towards the earth. But moon is, we are seeing only apple falling onto earth, but not the other way. Why that is happening? He seriously thought about it. To understand that, we will take up this activity 10.1 in the textbook. So take a piece of thread. Okay. Tie a small stone at one end. Hold the other end of the thread and then whirl it around as shown in the figure. Okay, this is the stone, this is a person, this is the rope, and he is whirling round and round. Note the motion of the stone. It is going in circles. It is like, this is like earth and this is like a moon. Suppose release the thread. Suppose if he releases the thread, what happens? That we have to think. Again, note the direction of motion of the stone. What happens to the motion of the stone when he releases the thread? This we will study in detail. We will draw a diagram as if we are seeing from the top the same experiment what we have done. So I will draw. This is roughly the direction of the stone. Okay, not perfectly circle. Then this is the position of the person, and let us take, this is the person of the stone, and this is the thread. Okay, this is the person, this is the stone. Okay, it is going round and round. Suppose if he releases thread, the thread is cut, then what happens? You can imagine it goes straight, otherwise it is going round and round. That means what? This position is continuously changing. See, if this thread is cut, the ball position should be here, but when it is going in circles with the thread, the ball position is here. That means what? Instead of here, it has moved here. It is coming closer to the person. Again, from here, it is coming closer to the person. So the position is changed, but the speed remains same. Speed doesn't change, but position is changing. Okay, this is what is happening. So this is what is happening. So I have put in the words. Here, the speed of the stone around the person is constant. This is constant. Speed is, it is moving like this. It is constant, not changing. But only the direction is changing. When thread is there, it is going in circles. So every point is keep changing the direction and maintaining the distance between the person and stone same. Otherwise, if there is a problem, it is going in straight line. Okay. So we understand from this, varying velocity is acceleration. We will try to understand what is varying velocity with acceleration. So I will write here, this you have to understand, this is very, velocity, you know, it is a vector quantity. It has got speed and it has got direction. This is velocity. It has got both. Now let us take changing speed or varying speed. But this we will keep it constant. Same direction. Speed is changing, but direction is same. So this we will call it as acceleration. This rate of change of velocity is acceleration. Here rate of change is with time direction is speed is changing. Let us take other condition. Here same speed. Let us take changing. That is the case here. So this is also called acceleration. So anyone, if it is changing, then it is called acceleration. It can be speed as well as can be direction. So in our case, this is true. Same speed, but continuously it is changing direction. So acceleration is happening, not velocity. So that's what we said here. Varying velocity is acceleration. That is what here is happening. It is going in acceleration, the stone, but the speed is same, but direction is changing. Okay, this you have to understand, please. Now, let us do some more analysis further. So, in a statement, it is like this. The force that causes the change in velocity keeps the body moving along the circular path. That is correct. So, if you take, going back to this thread, as long as thread is there, then if you are whirling this stone, you have to continuously pull the thread towards you, otherwise it will fly away. So again, we'll go back and read this. The force that causes the change in velocity keeps the body moving along the circular path. So what is happening here? There is a force from stone is getting attracted towards the person. So this force acts towards the center. It is acting towards the center. Okay, because of this force only, it is going round and round. Otherwise, it would have gone this way. So We will give a name for this. This force is called centripetal force. This is called centripetal force. So all these things Newton thought about it. Then he made a conclusion like this. The motion of the moon around the earth is due to centrifugal force. Centripetal force. Centripetal force. So the motion of the moon around the earth is due to centripetal force. Then the centripetal force is provided by the force of attraction of the earth. This is nothing but the centripetal force is like attracting these two, this towards this. If there were no such force, the moon would pursue a uniform straight line motion. If you consider this moon and earth, the moon will go straight instead of going in circles around the earth. So these three are very important conclusions. The motion of the moon around the earth is due to centripetal force. The centripetal force is provided by the force of attraction of the earth. Okay. If there were no such force, the moon would pursue a uniform straight line motion. We are not saying that. So continuously there is a attractive force. That moon is getting attracted by earth continuously. So this is what Newton thought about it, and then he thought there is a force here like that. So now we will take up another question. That is, it is seen that falling apple is attracted towards the earth. Does the apple attract the earth? Why we cannot think like that? Newton also thought, if earth is attracting apple, apple also should attract earth. Why he thought like that is because of the third law of motion. What is third law of motion? To every action there is an equal and opposite reaction. Okay. If the force of attraction, let us take apple attracted by earth is F, then apple also should attract the earth with the same force. That is what the meaning. That is what we understood. Correct. Then using this, because of this third law of motion, F should be equal to F. Now we will take up, if that is the case, let us take the second law of motion. For a given force, acceleration is inversely proportional to the mass of an object. Now we confirmed that there is a force and both the forces should be same. Apple attracting earth, or earth attracting apple, or moon attracting earth, and moon is attracted by the earth. All are same. Then second law is I studied just now. For a given force, acceleration is inversely proportional to the mass of the object. How is that? F is equal to ma, we know from the second law of motion. So this I will rewrite in such a way, a is equal to F by m. I can write like this. Further, if F is, I will take it as the same, then a is inversely proportional to mass. Correct. Inversely proportional to mass. Now we will take apple and earth, and then we will see earth will take, apple will take, we can take moon also. Let us take the mass of earth very, very high in comparison with the apple. Apple mass will be negligibly small. You can just ignore apple weight to earth weight. Earth weight is so huge. Then we will think of acceleration, that is A, using this equation. If mass is very, very high, then acceleration is very, very low. If mass is very, very low in this case, then acceleration should be very, very high. Very, very high. Correct. So here you see, in the case of apple, very negligible weight, the acceleration is very, very high with the same force. That means what? Apple accelerate towards earth very fast. Correct. Apple accelerate towards earth very fast. What is the other way? Earth hardly it will move towards the apple. Earth hardly moves towards the apple. So this is the reason. Because of the mass difference, you will see only apple falling to the earth, towards the earth, but not the other way. But it happens very, very minute. You cannot make it out. So with this kind of analysis, Newton concluded from the above facts, whatever he analyzed, all objects in the universe attract each other. Like apple attract earth, earth also attract apple, but only the accelerations are different. You have to mind it, forces are same. I told the forces are same, but only because of the acceleration, because of the mass, the acceleration is different. For one attraction you will see the for one mass you will see the attraction more, for the other one you will see very, very less. In the case of moon also it is same. Earth and moon. Moon is relatively very, very light compared to earth. So you will not see moon falling towards the earth. So with this, Newton first formulated a definition for gravitational force. It goes like that, like this. The force of attraction between objects is called gravitational force. So from this he concluded this is a gravitational force. So this happens whether it is a very, very small masses or very huge masses, or between very small mass to very big mass. Every two objects in the universe, it gets attracted. No repulsion. It will get attracted by the gravitational force. Here I want to tell you that one thing. We always see when something is falling. Apple is, you will take the case only, in this case only. Apple is falling towards the earth. Earth is not moving towards the apple. But imagine if there is an insect in the apple. That insect will see that earth is coming towards it. That is little bit higher subject. Those things you will study in the higher classes. Okay. Conclusion of this chapter.